Hi, I'm Spectre P. Welcome to the second video in this educational series on quantum security. My overarching goal is to show you that this quantum stuff is not as hard as it seems. The main thing is to approach it in a structured way. Examples in this field are very important, so we'll use lots of examples as we go. Let's dive right in. What is quantum security? Quantum security is simply the application of quantum computing to security matters, such as hacking, blue team, red team, encryption, secure communication, etc. Overall, it's basically applying quantum computing to data protection. So what is quantum computing? It's a bit funny that through my doctoral studies, I was solving the Schrödinger equation and realized that I had no idea what the whole point was. So this series of courses start with the very basics. Let me explain what quantum computing is in a way that will be easy to understand. Quantum computing is simply manipulating math, called quantum mechanics, through code, with the dual goals of managing wave amplitudes and interference. Now, what are wave amplitudes and interference? Amplitudes measure the strength of a wave, and interference is best understood with examples. Imagine you are in a bathtub. You use your left and right hand to push water together. Bam! The waves hit each other and become still. The waves have destructively interfered with one another. That's destructive interference. Conversely, when you push some water away from you gently and then use your other hand to push water toward the back of the first wave but with more force, the cumulative wave gets bigger. That's constructive interference. Let's bring this together now with the following example. Let's say the correct answer to a problem is simply the number 50. You have a classroom of students all calling out numbers of all kinds. Your algorithm then needs to constructively amplify the right number of 50 and destructively amplify all other incorrect numbers. The net result is that the right answer is louder than the wrong answers, which cancel out. That's it. That's quantum computing. When does quantum apply? Whenever you hear the word Planck. Max Planck was a Nobel Prize winning physicist during the Einstein era. You've heard of Planck's constant? Remember waves from above? Planck's constant links a particle's momentum to its wavelength. Momentum is simply mass times velocity, and wavelength is the distance between peaks or troughs of any wave. Planck's constant is 6.62 times 10 to the negative 35th joule seconds. Amazingly small. In addition to the Planck constant, there are typically 6 Planck quantities that are thresholds for quantum mechanics to apply. You can see them listed below, so you're starting to see the picture. Anything Planck is either tiny, extremely hot, dense, and energetic. Feel like a particle, huh? We'll go into a lot more detail on everything here in future videos. But for now, you have an intuitive understanding of what quantum computing is, what it does, and when it's applied. To summarize, quantum security is quantum computing applied to data protection, and quantum computing is manipulating wave amplitude and interference via code to obtain a desired result. So, if you understand quantum computing, you understand the building blocks of quantum security. Thanks for watching. Please hit the like button and subscribe. Check out our quantum security website on the web at SpecterAI.ai and our books on Amazon. The site has great research and resources. Register for free and enjoy. Sign up for the 55 realistic AI proctored labs to really learn quantum security. Leave a comment so we can make the channel better. See you in the next video.